All right, this is a video answer key to a polynomial review for you, as I promised. So let's begin. Can you multiply two binomials? You can definitely FOIL. First, outer, inner, last. I am going to draw a square, 2x and 10, x and 7. It just organizes it. It's called like an area model where you have length times width. I'm going to fill in each square. So x times 2x, 10x, 7 times 2, 7 times 10. Combine like terms, we have 2x squared. 10 and 14 together is 24x and then 70. Here I'm going to draw a rectangle. I'm going to make sure there are 3 columns for the trinomial. And the binomial will be on the side. Again, I'm going to multiply x times x squared, 2x times x, negative 7x, negative 11x squared. Negative 11 times 2 is negative 22x, and then negative times a negative is positive 77. Combine like terms and you get x cubed minus 9x squared minus 29x plus 77. One more time. This time it's y instead of x, but everything else is similar. The trinomial will go on top, the binomial will go on the side. Multiply 4 times 6 and add the exponents. 4 times negative 2, add the exponents. 4 times negative 5, we have a y. 11 times 6, 11 times negative 2, 11 times negative 5, which is negative 55, and then that's it. So it's 25y cubed plus, let's see, 66 take away 8. I can do that. 58. Negative and negative. You're adding negative, so it's negative 42. And then the negative 55. So first skill there, multiplying out. Next skill right underneath it. Can you factor? X squared subtract 16 is called the difference of squares. We take the square root of x squared. We take the square root of 16. And then difference of squares means one's adding and one's subtracting. That's it. Here is a simple trinomial. Two numbers that multiply to 100 and add to 20. That would be 10 and 10. Now we could write this answer as x plus 10, x plus 10. You could also write this answer as x plus 10 squared. This is useful when you're graphing because it matters if it touches or crosses. Writing it this way. Again, a simple trinomial, negative 48, negative 2. The numbers are negative 8 and positive 6. And that's it. That's the first page. Second page. More factoring. If I can pull this over. Anyways, more factoring. There we go. Not a simple trinomial. That means the power term is not a 1 in front, but a number other than 1, 7 in this case. 7 times negative 2 is negative 14 and 13 underneath. So the numbers are positive 14 and negative 1. So I'm going to take out 13x and put in 14x minus 1x. Then I'm going to factor by grouping. I'm going to take the first two terms. They have a 7 and x in common. To see what's left over, you divide. So 7 divided by 7, 1. 14 divided by 7, 2. Notice we have negative x and negative 2, so they have a negative 1 in common. That leaves you with x plus 2. Remember, you can distribute to make sure they're equal. Notice they have a common factor. That's good. That's x plus 2, and then the other part is 7x that's left behind, and subtract 1. That's factoring by grouping when it's not a simple trinomial. Here's another example. Can you factor this? Again, not simple. 6 times negative 6 is negative 36, negative 5 underneath. Two numbers that match are negative 9 and 4. So I'm going to take out the negative 5 and put in negative 9 and positive 4 in its place. I'm going to factor by grouping. let's see, I'm missing a 2 in here. So that should be a 2. Let me rewrite it nicer because I forgot. So take out a 3 and a z should be 2z minus 3. Take out a 2 and it is 2z minus 3. Notice how we have common factors. That's 2z subtract 3. And what's left when you take out a common factor is 3z plus 2. Alright, one more time. 3 times negative 20 is negative 60. 7 underneath. Two numbers that multiply to negative 60. Add to 7. Let's see. Go through the different lists in my head. So right now I'm thinking of 12 and 5. So 12 and negative 5. So take out the 7 and make it 12 and negative 5, which is 7. But now we can factor by grouping. The first two are 3x, and the next is negative 5. And you divide by seeing what's left over. Then the common factor is x plus 4, and what's left is 3x subtract 5. Alright, that's practicing factoring. Practice dividing. Can you divide these? We're dividing by a simple linear, so we're going to use synthetic division. And to use synthetic division, we use the 0 of x plus 2, which is negative 2. And then we have 1x cubed, negative 1x squared. We have no x's and a 4. So as you're doing the polynomial review, I would recommend that you try the question first. So press pause, do the question first, then play it and do it together. And if there's one mistake, press pause after that and continue, see if you can finish it to the end and see if we match our answers. Alright, so I'm going to do synthetic division, drop down the 1, multiply, add, and I have 4. Now there is a remainder here. I was going to say no remainder. That's okay. We're not testing to see if it's a factor. It's not a factor. We're just dividing. So the answer then, our dividend was x cubed, so our quotient, our answer, starts with x squared. So 1x squared minus 3x plus 6. Remember to write the remainder as a fraction. So that's 8, the remainder, over the divisor, which is x plus 2. Number 11, you can't divide this using synthetic because it's not linear. It's x squared. So we have x squared plus 1, and we're going to divide it into x to the 4th. Now I am going to include this. I may not need it. 0x cubed, but it's good practice. 0x and 8. And again, I may not need those zeros, but I might need those placeholders. So we'll see. So we'll start with power over power. So when I divide x to the 4th over x squared, I subtract the exponents to get x squared. I'm going to multiply and make sure I put them under like terms. So when I go x squared times 1, it's not going under x cubed, not like terms. It's going to go under the other x squared, so they're like terms. X to the 4th cross out. 4 take away 1 gives you 3x squared. Bring down the 8. We're not going to need the 0x. 3 divided by 1, just 3. The x squares cross out. And notice we have like terms there, so we didn't really need those, but we might have needed them. Subtract, the remainder is 5. So again, we write the remainder as a fraction. So 5, and then the denominator is what you divide it by. So that's long division. Oh, here, let me make sure you can see it all. So I was talking there. So again, follow each step there. All right, turn the page. All right, for each point, for each function, analyze and sketch it, and then find the intercepts and multiplicity and behavior and approximate some turning points if you need to. All right, so step 1 is I'm going to factor this. So they have a 2 and an x in common. I'm left with 2x squared minus 4. X squared minus 4 is a difference of squares. Take the square root of both, and you get x plus 2, x minus 2. So we have the expanded form and the factored form now. So it should be easy now. So the power term then comes from the expanded form. It's positive with an odd exponent. So that means the right end goes up and the left end goes down. The zeros in multiplicity come from the factored form. So 2x gives you 0, and the exponent is 1 that you don't see, so it's going to cross. The next factor, -2. And again, the exponent's odd. It's 1, so it's going to cross. And the last one's +2. And again, the exponent's odd that you don't see, so it's going to cross. The y-intercept. So we can, from the expanded form, there's no constant at the end you see. So actually it's 0, right? And if you plug in 0, the answer is 0. So we're going to sketch this. Going to put down the intercepts, 2, -2, and 0. So I know the right end goes up and the left end goes down. Again, anytime you want to press pause, you do it first, then press play and see if it matches. To find the turning point between 0 and 1, I'm just going to estimate it using 1. So if I plug 1 in, you can use any form here to get the answer. I can use the factored form. So 2 times 1 is 2, 1 plus 2 is 3, 1 take away 2 is -1, so this whole thing is -6. So at +1, it's going to go down to -6. We're also going to use -1. So if I put in -1, how does that change the answers? I think it's going to be similar. So -2, 1, and -3. This time it's +6. So I'm going to count down to -6, count up to +6. Put down approximate turning points. And there you go. So again, press pause anytime you want, and then you can do the work you need to do. For 13, it's factored already for us, so we'll get started. Power term is by multiplying 2 times x cubed, so that's 2x to the 4th. The end behavior, the right end is going up, the left end is also going up. Notice it's positive with an even exponent. 0 is the multiplicity. 2, this 2 in front, no 0. So if I just take 2, make it equal to 0, there's no x to solve for. So 2 doesn't equal 0. There's no 0 that comes from just 2. It needs a letter. The next factor, x minus 7, +7, it's going to cross. And then x minus 6, +6, and it's going to cross because of the odd exponents. The y-intercept, and this is going to be a crazy y-intercept. So when you plug in 0, you get a very large number. So we're going to just estimate the curve of the graph. Like I'm going to use a calculator because I'm just not in the mood to go 6 cubed. So 6 times 6 times 6, again, it's 216 times 7 times 2, 3,000 something. So that's just ridiculous. So the negative times the negative times the negative, so you end up with 2 times -7 times -216. Altogether, that's positive 3,024, whatever. We're just going to estimate and sketch where it crosses and where it touches, even for the turning points. Obviously, on a quiz or test, I don't want to give you something to graph where you have to count up to 3,000, so I'm not quite sure. It must have slipped by as I put this equation in. All right, so find where 6 is, find where 7 is. So 1, 2, 3, 4, 5, 6, and 7. Oop, there's 6, there's 7. They're really close to each other. We know the right end goes up, and we know the left end goes up, and we know eventually it would, at 3,024, it would eventually hit the y-axis, so it's definitely not going to hit the y-axis right there. And then when I look, somewhere in here there's a turning point. So you could put in 6.5 and estimate it. What I care about is to understand that it crosses at both and then it turns. So I'm not worried. That's a skill to use with a graphing calculator. Calculus could give that skill. Right now, where the end's going, did it cross? There's some turning point there, and I'm fine the way it looks. Press pause and do 14. Okay, now it's my turn. Power term, x times x times x, x cubed. End behavior. The right end goes up, the left end goes down. zeros in multiplicity, I had -3, +4, -4, all of them cross. Y-intercept, it's going to be another big number. So the y-intercept 0 plus 3, 0 take away 4, 0 plus 4. So you're going to go 3 times -4 times 4. So it's -48. Not as big as 3,000, but still going to be beyond what I care about. And then sketch it. So I care about -3. I care about -4. They're very close to each other. I care about +3. No, +4. That's right there. All right, so I know the right end goes up, the left end goes down. I know that somewhere here at -48, right, that's kind of like it's going to turn. So wherever -48 might be down there, right? And then here, this one wouldn't have, because they're so close together, this wouldn't be as big of a turning point in terms of how high it is. But you can get the general shape of the polynomial by simply knowing the end behavior and what's happening at each intercept. So each one's crossing. And if the two intercepts are really close together, it won't go very high. But if there's a big gap, chances are it's going to get quite low or quite high. All right, turn the page. Last question. Press pause. You first, then me. So press pause and try it, then press play. All right, my turn. So power term, -2x squared times x is -2x to the 4th. You have to add the exponents. That means the end behavior, the right end is going down because it's negative. The left end is also going down because an even exponent means both ends go in the same direction. Zeros in multiplicity. So -2x squared gives you the 0, 0. Has an even exponent. X subtract 6 gives you +6. It's going to cross. And +4, it's going to cross. Again, y-intercept actually isn't bad this time because when you multiply -2 times 0 squared, and then 0, -6, 0, -4, what you end up with is -2 times 0 times -6 times -4. So that 0 in the middle makes everything 0. So 0 times anything, the answer is going to be 0. So let's graph this. So we have 0, we have 6, we have 4. It says 0's here. So the right end and the left end go down. At 6, 4, there's going to cross here. So we could put 5 in to estimate it. I have a feeling if I put in 5, it's going to be ridiculous. Because already 5 squared is 25, -50. These will be 1s, -1. 5 take away 6, -1. 5 take away 4, +1. So it's -2, 25, -1, +1. So it's going to end up being +50. So, I mean, if I was going to be super accurate, which is always nice to do, it actually would go way, 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 and then some number between 0 and 4, like 2. And again, if you plugged in like 2, what would happen? -2, 2 squared, 2 take away 6, 2 take away 4. So it's -2 times 4 times -4 times -2. Geez, 4 times 4 times, so it's 64. Right, 8 times, yeah, it's -64. So, I mean, 50, this one goes all the way down. But then, I know it touches at 0 and then goes down. So these turning points are a calculus skill. It's a graphing calculator skill. We're estimating them. I care about the end behavior. I care about the behavior at each intercept. And the turning point part, we're just estimating. All right, that's analyzing graphing polynomials. Now the last part is be able to solve equations or just to find zeros. So I don't care about whether they cross or touch or the end behavior. Right now I'm just looking for the zeros. And another way is just to make it equal to 0. It's the same skill. So if this said y equals or equal to 0, it would mean the same thing in terms of finding the zero. So again, press pause, you do it, then me. All right, my turn. So first I'm going to look to see if I can factor it by grouping. So if I take the first two and I take the next two, they are not going to match. So they don't have a common factor. So I need to do the rational zero theorem. So the good news is I only need to find one that works. So 6 is 1, 2, 3, and 6. Those are the numbers that go into 6 evenly. Synthetic division, 1, 2, negative 5, negative 6 does not add up to 0. So I'm going to skip 1. Negative 1, 2, negative 2, those are the ones I'm going to try. So negative 1 works. That means that x plus 1 is a factor, 0 factor. What's left is x squared plus 1x minus 6. So if I do a diamond, negative 6 and positive 1, that would be positive 3 and negative 2. Those are factors, positive 3 and negative 2. Now I can solve for x. So if I'm solving for x, the first factor gives me answer negative 1, then negative 3, and then positive 3. Do you have the skill to write it in factored form and to solve it? All right, 17. You first, then me. So press pause and try it, and then I'll do it. All right, my turn. So I'm going to first start again to see if I can factor by grouping. So I'm going to go x squared, 2x minus 1, and then I already have a 2x minus 1, so only a 1 in common factor, which is great. So I have 2x minus 1, x squared plus 1 equals 0. So if I take each factor equal to 0 and solve it, I get 2x minus 1, add 1, divide by 2. One answer for x is 1/2. That's a real answer. The other is x squared plus 1. Take that equal to 0 and solve it. So subtract 1. When you take the square root of a negative number, we know the answer is imaginary. So the letter we need is I, and the square root of 1 is 1. So I don't need 1i, just I goes. But it's a quadratic, so the answer is positive and negative. So remember the fundamental theorem of algebra. The degree is 3. We found 3 solutions, positive and or real and complex. 18, you, then me. So press pause, you do it, then I'll do it. All right, my turn again. So x squared, x minus 1, 16x minus 1. So this can be factored by grouping. Recognize that one answer here, so x minus 1, the factor there is a simple linear, so the answer is positive 1. The one above here, 2x subtract 1, was not a simple linear because it took 2 steps to solve it. But this one's simple. X squared plus 16 by itself equal to 0. Subtract 16. When you take the square root of a negative number, it is imaginary. Square root of 16 is 4, and it's going to be positive and negative because it's a quadratic. So we have positive 4i and negative 4i. Again, fundamental theorem of algebra, the 0 tells you, or the degree tells you the number of zeros to find, and we did. We found 3 of them. All right, last one. So press pause. You, then me. All right, my turn. So this one is in the form of a quadratic. So I'm going to go 36 and 13. So that's 4 and 9. So I have x squared plus 4 and x squared plus 9. Now, recognize that normally we go x plus 4 and x plus 9, but we changed the exponent to 2 so it would match the exponents that are there. So this is a simple trinomial. We just need to change the exponents so they fit. Each factor equal to 0. You might recognize that both of these are going to be imaginary, both. So they're not a difference of squares because you're adding. So you're going to subtract 4. When you take the square root, the answer is positive and negative. The square root of 4 is 2. The square root of negative 4 means it's imaginary. So again, subtract 9, square root both sides. So the square root of means the quadratic positive or negative. The square root of 9 means the answer is 3. And the square root of a negative number means it's going to be imaginary. So we have 4 answers. All 4 are imaginary. And it said we have 4 solutions. That's the fundamental theorem of algebra. All right, good luck working, studying, doing ALEKS, and everything else you need to do to be successful. We will soon be making up these quizzes. All right, bye. Mr. G Math, right? Over now.